Okay, in this question, we're given a function y equals f of x. The curve crosses at p0, so the curve crosses here at p0. It crosses the axis at p0 and 0q, so there. And the lines x equals 1 and y equals 2 are asymptotes. That means at x is 1, the curve goes up off to the asymptote here, and this part of the curve goes down to the asymptote here. And y is 2, as you go from x to infinity, this part of the curve tends to y is 2 from above. And as you go from x to negative infinity, this curve tends to y equals 2 from below. Showing the coordinates of any intersection with the axis and the equations of any asymptote sketched on separate diagrams, y equals the modulus of x. I'm going to actually do that over here. Y equals the modulus of f of x. So y equals the modulus of f of x. Now you should know what this the modulus of a function does. What it does is it allows you to have all the function you had before, okay? But anything below the axis, like here, will be reflected above the axis like that. So it's going to be this exact graph here, apart from the fact that anything where you've got your f of x being negative is going to be reflected up here to being positive. So to try and draw those in, let me just draw the asymptotes. The asymptotes are here and here, like that. This is exactly as it was. This is exactly as it was up until this point here, where then it would go up to infinity like that. So the coordinates here still would be 0q. This here, sorry, this would be 0q here, and this here would be still p0. Don't forget to label in the axis. This would still be x is 1 as an asymptote, and this would still be y equals 2 as an asymptote. Okay, the next part, we're trying to draw y equals 2 f of x add 1. So 1's inside the bracket, 1's outside, so the order doesn't matter. So let's do it in, what we're going to end up doing is this part here is going to shift the curve by 1 unit to the left, and this here is going to stretch out by a factor of 2, everything. Okay, so we could probably just draw it straight in one move then. So what I'm going to do, let me just actually just copy this here, so I've got a copy. So let me just wipe that out first. Okay, here we go. So there we go. There's our original. And what we're going to draw is 2 f of x add 1. So what's going to happen to our asymptotes? Well, y equals 2 f of x . 2 f of x add 1. Now this asymptote here is going to shift 1 unit to the left. So our asymptote here is going to actually shift 1 unit to the left, and it's going to be the asymptote x is equal to 0. What's going to happen to this asymptote? Well, it's going to be doubled up to y equals 4. So this asymptote here is now going to be y equals 4. Like that. Okay? So what's going to happen to this point here? This was at p0. Okay, so it's going to be shifted by 1 unit to the left. Now, does it tell us how big p is? Well, p is obviously less than 1, because this is the line x is 1. So we shift it 1 unit here, it would be over here somewhere. So it would be at p subtract 1, 0. Now what's going to happen to this point here, 0q? Well, now it's going to actually be at, it's going to, this point here would have been, it would be back at -1, and it would be at 2q. So -1 and 2q like that. So let's see if we can draw this in. It would look something like this. Like that. And then something up there like that. Okay, now we're also given what f of x is. We're actually given that f of x is equal to 2x subtract 1 divided by x subtract 1, where x, what's it allowed to be, what's its domain? X is a real number, but x cannot equal 1. And it says find the values of p and q. We'll look up here, the values of p and q where it crossed the axes. Okay, so firstly, let's let x equal 0. If x is 0, then f of 0 is equal to 2 multiplied by 0, take away 1, divided by 0, take away 1, which is going to be 1. So f of 0 is 1. So we know that the graph goes through 0, 1. Now for the other, so 0, 1 is therefore going to be 0q. So that's the same as 0q. So therefore our q is equal to 1. Now for the other one, we're going to set f of x to be 0. We're going to set the y number to be 0 and see what x gives you that. So 2x subtract 1 over x subtract 1 is 0. Multiply both sides by x subtract 1. Get 2x subtract 1 is equal to 0. And then solve this, add 1 to both sides and divide by 2. X is a half. Okay, so we know that a half, 0 goes through this, which was our p0. So therefore p is equal to a half. So underline that as follows. And we found our p and our q. And then it says find an expression for f inverse. So this is quite a nice straightforward. We let y is equal to 2x subtract 1 over x subtract 1. We swap the roles of x and y. So x equals 2y subtract 1 over y subtract 1. And we try and make y the subject. So multiply both sides by y subtract 1. X, y subtract 1 is 2y subtract 1. xy, take away x, is 2y subtract 1. We're making y the subject here, so bring everything with y to one side, subtract 2y off both sides and add an x. xy subtract 2y would be equal to x take away 1. Factorise the y, get the following, and therefore y is equal to x subtract 1 over x subtract 2. And then state that therefore f inverse of x is equal to x subtract 1 over x subtract 2. There.